When exploring data, histograms are a type of plot that can show the underlying frequency distribution, or the shape, of a set of continuous data. Remember that continuous data is numerical data that can have any value between 0 and infinity. So, for example, age is a continuous data set. Using a histogram allows us to look at the data and find its underlying distribution, its range, and look for things like outliers or potential skewedness of the data. So here, we have a series of numbers that represent the age of the people in our sample group. What we want to do is construct a histogram for these ages to see if we can find any trends. So step 1 will be constructing a frequency table. This table will break up our data into different bins or smaller groups and tell us the frequency of how often a number falls within that group. So here, if we look at our range of data here, it looks like our smallest number is 25 and our largest number is 91. So the easiest bins that we can create are tens, or the 20s, the 30s, the 40s, etc. Once we have our different bins set up, we can then look to our data and see how many data points fall within each of these bins. So let's start with the 20s. We see that we have 25 and 22 in our data set, so the frequency here is 2. Next, for the 30s, we have 36, 38, another 36, and another 38. So that's a total of 4. Continuing in the same manner, in the 40s, we also have 4 data points. In the 50s, we have 5. In the 60s, we have 3. In the 70s, we have 1. We don't have any values for the 80s, so we'll leave that as 0. And we have 1 value in the 90s. So far, from our frequencies, we can see that we have a peak in the 50s, but we can see this best by graphing this out. So we'll graph this with our different bins on the y-axis and on the x-axis and our frequencies on the y-axis. So this is what our blank histogram looks like. We have our age and our frequency denoted as f. Each bar will go across and reach 2 of these lines. So for example, the bin for 20 and through 29 will start at 20, go up to a frequency of 2, and then connect over to 30. What's very important to note about a histogram is that each bar must touch bars on either side, unless, of course, there's a 0 at that point, which we'll see in this graph. Let's go to the next bit for the 30s. This is a frequency of 4, so we'll go up to 4. The 50s also has a frequency of 4. For the 50s now, we'll go up to a frequency of 5. For the 60s, we're at a frequency of 3. Next, a frequency of 1. Now here we have a frequency of 0, so we won't draw anything in. And for the 90s, we again have a frequency of 1. So this is our final histogram. Notice that there are no gaps in between the bars, and that from here, we can see that we have a peak in the 50s. We also see that most of our data is in the lower ages, and we have a slight skew to the right. Now notice that when we say a skew, we label the skew based on where our outlier data resides. So this is a right skew, even though most of our data is located on the left side of the graph. Also notice the main difference between a histogram and the stem and leaf plots and dot plots we looked at earlier. A histogram doesn't show each individual piece of data. Instead, it groups data into different bins and shows the frequency of those bins occurring. So we lose a little bit of the details of our data. For example, in the 50s bin, we could have had all 5 values be 51, with no values above that in between 52 and 60. But this type of graph wouldn't show us that information. However, it is crucial in showing us the spread of our data and any potential outliers. For example, the data considered in this peak here may be an outlier.